Hello and welcome to Advent of Code. What day is this? Day 6, about 35 seconds before the next problem becomes available. And let's see if I can set up my Alt tab here. I've been missing that the last couple of nights. Okay, this feels pretty good. Yeah, yesterday's problem was pretty straightforward. Our first sort of implement a computer problem. Let's see where day 6 takes us. About 5 seconds to go. All right, here we go. Oh no! All right, debugger program. 16 memory banks, each holding blocks. Balance the blocks between the banks. Banks start here, chosen, starting with the next one. Okay, so this kind of seems like, okay, the fourth, okay, yeah, all right. So the answer is 5. All right, here's our puzzle input. All right, this looks tab separated. So let's see if our input here looks okay. That looks pretty good. So what we've got to do is, I think, define a step function. So given a state here, let's see. So we got to find the one with the most blocks. So maybe something like, so how do you find that? Maybe we could do like a map indexed here, and like a sort by the second, and then take the last of these and then return the first here. That's pretty ugly, but I think it'll work. Okay, this is saying 7, which is likely this 15. All right, so let that be I, and then let's see. The second bank is chosen, fourth bank, third bank, and the same thing happens. Okay. So so the question is, how many redistribution cycles? So what we basically do is we're gonna, all right, so I think we can let ij be these numbers here. And then we're gonna say, make sure we still have our connection here, good. We wanna do something like a reduce, starting with S, and then our function is going to be, actually, what we're going to do is we're going to say update in our state S, maybe a SOS actually. We index I at 0, and then we'll do a reduction function that's going to be taking, I guess, some number n here, and it's going to work by updating S, where we take like the remainder of n and the count of S with an increment. And then the collection that we're going to be working off of is going to be iterate inc starting with, I guess, 1 more than I, and then we want to repeat this j times. All right. So a single step here says wrong number of args passed to persistent vector. Let's see. So my guess is it's where we're doing some kind of lookup. Let's let's see. So update S. So maybe here. Oh yes, right. The function comes first, and here's our starting state. So, all right, can't iterate over a number. Iterate inc on. Okay. Right. This shouldn't be a repeat. It should be a take. Okay. All right. So this looks like a distribution did happen. Tentatively, it looks correct. So we want to do something like take the reductions on, nope, something like iterate on step with our starting input, and then maybe start with a map. So how do we want to say this? We want to say maybe let M be like sort of this set here, and then do seek for each of these states. Maybe change this to like a loop here, and then does this make sense? Yeah, I think so. So we'll have a state that we're looping over, which will just be input, and our starting state will be there. We'll recur on step on the input, and conj, let's see, here. We want to add into this map the new set, and then our, we'll have one more sort of state variable that we're tracking here, and then we just want to do a check in our list of things that we've already seen. If we've already seen this state, then I think we want to return our value n. All right. Loop requires an even number of okay. So let's see, how many steps do we start in? So let's see, 0, 1, 2, 3, 4, 5. Okay, so I think this is initialized to okay. If m, okay, so this is saying, so something about step on input is saying that it's like it's the same thing. That this doesn't look the same to me. No, these are all different. Let's see. So doing m on so I don't think yes, this makes a difference. Yeah. Okay. Giving the same right, like this. All right, answer 722. All right, not the right answer. Okay, possibly we got an off by one error. It's a very precise kind of answer here. So let's see. I bet if I emitted maybe the state that we sort of ended up in here, then what we could maybe do something like iterate, maybe like so maybe something like call this maybe we could say something like when SS is equal to this thing here, notify us. So this, according to this, it says that in step 706. So this must be an off by one error. So at this point, we reached the third bank is chosen, and the same thing happens. 2, 4. Okay. After the 5th block redistribution cycle, so seems like we start with 0. We start with our initial state. I mean, I can try 7, maybe 721, but that would just be a guess. How many redistribution cycles must be before a well, let's see. So one cycle and then another cycle. I mean, it really does feel like 720, 722. Maybe I have a bug. That is a possibility. So let's try it with this input here. 027. So let's let this be here. Produces 4. Oh, okay. All right. In that case, 723. Not the right answer. Oh, interesting. Huh. Well, so I guess let's see if it returns the correct final state. So yeah, and then if I guess for some reason n has to be initialized to 1, so this gives the right answer. I wonder if I hope it's not an issue with the doubles being equal again here, but maybe just to be safe, we should change this to integer int here and redefine our input and run this again. All right, we want to say this is on input. There is 723, which is what we guessed. The infinite loop is detected. How many redistribution cycles must be completed until it runs out of blocks? If it reaches the last memory bank, it wraps around to the first one. Well, I guess let's check each individual step. So if we have something like iterate step like this here, and then we take, we want to take 5 of these. So, oh, okay. All right. Wait a minute. Looks like looks like I did the wrong thing here. Yeah, I didn't pay attention to how ties are won by the lowest number memory bank. Yep, that'll do it. So in this case, we need to sort by the second thing first, and then let's see. So I think like this. All right, and then that looks right, and then here. Okay, produces a new answer. Let's try this. All right, 1 gold star, 347. Let's see what part 2 gives us. Also like to know the size of the loop. Starting from a state that has already been seen, how many block redistribution cycles must be performed before that same state is seen again? Oh, okay. So this should be pretty straightforward. So we can repurpose our printer here. And then we just have to do a subtraction. So take 14029 and subtract 11264, giving 2765. Right answer, 224. Haha. All right. Well, a little bit better. Let's look at the advent calendar. Oh yeah. Okay. Small one on this refresh, and a rather more complete one this time. It is fun to watch the calendar change. Yeah. Let's talk about the problem. So, I got snagged up in a couple different places. So this problem actually reminds me of what is the name of that board game? Mancala, something like that. Yeah. Yeah, so in this game, basically the way that it's played is that you have a, let me see if I can find a better picture. But you have sort of a number of beads in trays here, and there's sort of an order to them, and then you pick up all of the beads in a single tray, and then drop one in the first, another one in the next, and so on. And yeah, there's some kind of, I don't know, win condition. But so that's what it reminds me of, which is basically uh, using an algorithm like that to do balancing of numbers. Okay, so how did we implement it? Well, in the first case, I had a fairly rough time getting the index of the greatest element, and that's pretty that was pretty surprising to me that that the way to get that wasn't immediately obvious. I'm thinking right now about, so the way that I ended up doing it was I created sort of like a list of tuples here. So given input like this, then I did a sort by on this, and then took the last one of these. I guess instead of using a sort by and the last, I could have just done a max key. So this is just basically like a linear way to do the same thing, which is that you want to get, what it's going to do is it's going to apply this function to every element in the collection and return the value for which it produced like the highest thing. So in this case, I could use the same function here. Using juxt is a way of defining a like sorting or scoring function that takes this function first and then this one next. And if I had more, I could put them here. So persistent vector can't be cast to number. Oh, right. Yeah. Okay. So max key wouldn't have been the best thing. It can still be used, but the problem with max key is that it uses numeric comparison rather than like Java comparison, compare to. So the other way that I was thinking about doing this was combining these two numbers in a way where the second number was always going to be bigger than the first. So you could do something like add the second one of these numbers to something like, you should be able to just say divide the first of these numbers by 1. Does that make sense? Because you need, yeah, you need bigger values to become smaller. So in this case, divide the add. Oh yeah. So yeah, I guess I'd have to think about the way to turn this into a number. Let's see. So the first of these numbers. So if it's something. So this is going to be the index. Yeah. So maybe I could just. Would this do the right thing? Yeah. So basically, struggling with this makes this implementation a lot maybe faster to do. So in any case, so we pull out our index and the actual value here, and then I use a reduce. So here, basically, what we need to do is, so the first thing that I did was I started to generate the numbers that start from 1 greater than the index, and I took I took j of them. So this is basically like taking that many values up in my hand, and then what I'm going to do for each of them is I'm going to sort of modify this state here to increment the number of things at each index based on for as many of these j's that we have. And I used rem to basically get the wraparound behavior. And then this is the only other snag here, which is that you need to take all of the beads out of the initial bowl. So so yeah, that was pretty much it. And then my implementation I wasn't so super satisfied with this. I was watching some solutions to previous nights in Ruby and Python, and I think I've been in sort of like an iterative kind of mindset. So this the solution kind of reflects that. If if I was doing things in maybe more of a like functional mindset, then I might be thinking about the kind of function that like returns you know, like some kind of like take until repeat or something here, and it might take like some kind of collection and then return those elements of the collection that up to and including the first repetition. So yeah, and so that might be you know, then you could just sort of like take the count of this. But the implementation that I did settle on was yeah, using a couple like loop variables here, and just having a closure set. Confusingly named given m, but yeah, basically advancing by one step at a time, and then taking each of the checking to see if the set is if the state is present in the set of states that we've seen already, and if it is, then return. Otherwise, just return. So yeah, pretty straightforward problem with a couple of snags. The main ones just sort of being around like the structure of the program, and being sure to use both comparison methods here. Yeah, I mean, even though I sort of got stuck and submitted two wrong answers, still was in the 300s and 200s. So I think that if I you know, do a little bit more practicing and think about what the you know, better closure way of solving these is, then I should have some better luck on future nights. So as always, thanks for watching, and I will see you tomorrow.